On November 12, 1942, an extraordinary scene unfolded on the shoreline of Richmond, California, inside the fenced boundaries of Permanente Metals Corporation's shipyard No. 1942. A massive steel cargo ship stretching 441 feet from bow to stern and weighing more than 28 million pounds stood poised to enter the waters of San Francisco Bay. What made this moment remarkable was not the ship's size, but the astonishing speed of its creation. From the first steel cut to final assembly, the vessel had been completed in just 4 days, 15 hours, and 29 minutes. For generations, shipbuilding had been defined by patience and tradition. Since long before the birth of the United States, vessels of comparable scale typically required 6 to 8 months of skilled labor in conventional shipyards. Yet here, in the middle of a global war, a fully operational Liberty ship awaited launch after less than a week of construction. As the ship stood ready, more than 1,000 workers stepped away from the hull of the SS Robert E. Peary. They were not seasoned shipwrights trained through years of maritime craftsmanship. Instead, they were men and women drawn from across American society, former office clerks, agricultural workers, homemakers, and manual laborers, many of whom had learned welding techniques only weeks earlier. Their work challenged centuries of industrial assumptions. Nearby, a crowd of government officials, newspaper reporters, military observers, and rival shipyard executives gathered to witness what many would later recognize as a turning point in industrial history. This launch symbolized more than a single ship. It marked the emergence of a radically new approach to manufacturing. The outcome of the Allied war effort, it seemed, was being shaped not only on battlefields but on factory floors measured in output charts, production rates, and efficiency metrics that shattered long-held beliefs about what was industrially possible. The roots of this transformation trace back to December 27, 1940. On that day, Henry J. Kaiser signed his first-ever shipbuilding contract. At the time, Kaiser was an unlikely candidate to reshape naval production. He had never built a ship, never overseen a shipyard, and possessed no formal background in maritime engineering. His career had been spent managing colossal infrastructure projects, moving mountains of earth and pouring vast quantities of concrete to construct dams across the American West. Despite this, the 58-year-old industrialist made a bold commitment to the United States Maritime Commission. He promised to deliver 30 cargo ships for the British government within a 2-year period. Established shipbuilders reacted with skepticism, if not outright dismissal. Many viewed Kaiser as an outsider chasing wartime profits without understanding the complexity of ship construction. Todd Shipyard's Bath Iron Works, one of the oldest and most respected shipbuilding firms in the United States, agreed, somewhat reluctantly, to collaborate with Kaiser. The assumption was clear: Todd's experience would compensate for Kaiser's lack of maritime knowledge. What few realized at the time was that Kaiser's unfamiliarity with traditional shipbuilding would become his greatest strategic advantage. Among the observers following these developments closely was William Francis Gibbs, widely regarded as the nation's foremost naval architect. His firm, Gibbs & Cox, had designed the Liberty ship based on earlier British cargo vessel plans. Gibbs had spent decades designing ships and understood maritime engineering at a depth few could match. Compared to him, Kaiser was a novice. Yet it was precisely this difference in perspective that would spark a revolution. The shift began quietly in early 1941 within the planning offices of Todd Shipyards in New York. As Kaiser and his engineering team studied conventional shipyard workflows, they quickly concluded that traditional methods could never satisfy the urgent demands of wartime logistics. The pace was simply too slow. Kaiser's chief engineer, Clay Bedford, brought a crucial insight to the table. Just weeks earlier, he had toured a Ford Motor Company factory in Detroit. There, he observed automobile frames moving steadily along assembly lines, with workers installing standardized prefabricated components at precise stations. The process emphasized speed, repetition, and interchangeability. Bedford returned to California convinced that ships could be built using the same principles. Instead of crafting vessels piece by piece on the slipway, he proposed assembling large sections in advance and joining them together in a streamlined sequence. To traditional shipbuilders, the idea bordered on heresy. Ships, they insisted, were not automobiles. The first truly disruptive proposal followed soon after. Kaiser suggested abandoning rivets altogether. For centuries, ship hulls had been held together by rivets, metal pins heated until red hot, driven through overlapping steel plates, and hammered into place by highly coordinated teams. Even the most skilled riveting crews could install only about 100 rivets per day. A single Liberty ship constructed using this method required close to 1 million rivets. To Kaiser, this represented not craftsmanship but inefficiency. What followed would redefine industrial production, proving that speed, scale, and adaptability, not tradition, would determine victory in a modern war. Henry J. Kaiser challenged one of the most deeply rooted assumptions in naval construction by advocating for the widespread use of electric arc welding. It was not a theoretical idea for him. Kaiser had already refined this method while constructing long-distance oil and gas pipelines throughout the rugged terrain of the American West. To him, welding was faster, more flexible, and better suited to mass production than traditional riveting. The proposal, however, landed on the desk of Vice Admiral Emory S. Land, the formidable head of the United States Maritime Commission, where it was met with serious doubt. Land was no innovator by instinct. Letters and memoranda he exchanged, now preserved in the National Archives, offer a clear picture of the maritime establishment's anxiety. Large-scale welded hulls had never been tested under combat conditions. Even the Royal Navy, fighting for survival, strictly prohibited welding on the structural hulls of its warships. From Land's perspective, Kaiser was asking the United States to gamble its entire logistical lifeline on a method that many professionals considered experimental at best and reckless at worst. Yet skepticism existed alongside a growing sense of alarm. German U-boats and surface raiders were inflicting catastrophic losses across the Atlantic. Allied ships were being destroyed at a rate that conventional shipbuilding simply could not match. By the end of 1941 alone, roughly 3.6 million tons of Allied merchant shipping had been lost to enemy action, accidents, and weather. Britain's situation was dire. Food and fuel shortages were no longer abstract threats but daily realities. Meanwhile, American shipyards relying on traditional techniques required, on average, more than 7 months, about 230 days, to complete a single cargo vessel. If that pace continued, the Battle of the Atlantic would be decided long before American factories could tip the balance. Approving Kaiser's contract was therefore not an endorsement of his ideas so much as an act of strategic desperation. The nation could not afford caution. What followed was one of the most radical industrial transformations in American history. Between January and December of 1941, a vast shipbuilding complex emerged from what had previously been little more than muddy tidal flats along the Richmond shoreline in California. Kaiser's crews, many of whom had built dams, bridges, and highways rather than ships, constructed a facility that stunned and unsettled traditional naval engineers. Instead of the towering gantry cranes, narrow slipways, and linear workflows typical of established shipyards, Richmond resembled something entirely unfamiliar, a factory modeled after automobile assembly plants. Massive open zones were dedicated to prefabrication, encircling 7 parallel launching ways. Steel components were built in sections rather than as part of a continuous hull. Rail lines cut across the yard, allowing enormous prefabricated units, some weighing as much as 150 tons, to be transported with mechanical precision. Overhead cranes, placed at regular intervals of roughly 100 feet, were powerful enough to lift entire sections of a ship in a single motion. In May 1941, John Riley, chief naval architect of Bethlehem Steel and a man with 3 decades of shipbuilding experience, toured the Richmond yard. His assessment, classified as confidential at the time, reflected both disbelief and reluctant respect. By his own admission, nearly everything about the layout violated the principles he had been taught throughout his career. The prefabrication zones were far larger than any he had seen. The cranes were excessively powerful by conventional standards. The building ways were unusually short. And yet, Riley conceded that the design was logically aligned with Kaiser's stated goal, assembling ships at unprecedented speed from standardized sections. The final and perhaps most revolutionary element was the workforce itself. Traditional shipyards depended on long-established maritime communities where specialized skills were passed down through generations. Kaiser rejected this model entirely. He placed advertisements in newspapers across the country, offering pay rates roughly 20% higher than typical industrial wages and promising to train anyone willing to learn. Prior experience at sea was not required. When the first waves of workers arrived in Richmond in August 1941, they represented a cross-section of America rather than a maritime elite. The work itself was broken down into simplified, repeatable tasks, an approach borrowed directly from mass manufacturing. Complex shipbuilding operations were transformed into sequences that could be mastered quickly and performed efficiently. The results were dramatic. By October of that same year, more than 10,000 people were employed at the Richmond shipyard, yet fewer than 200 had any prior experience in ship construction. What had once seemed like industrial heresy was rapidly proving to be a powerful weapon, one forged not from tradition but from necessity. For generations, becoming a skilled welder meant committing years to formal apprenticeships. Traditional shipyards expected workers to spend as long as 4 years mastering every possible welding technique before being trusted on critical projects. Henry J. Kaiser abandoned that model entirely. At his shipyards, instructors focused only on the exact skills each worker needed for a single, clearly defined task. Training that once took years was reduced to roughly 2 weeks. Workers were not expected to understand every aspect of ship construction. One group learned only how to weld vertical seams on bulkheads. Another specialized exclusively in horizontal deck plates. Others repeated the same curved welds on hull sections day after day. This extreme specialization was intentional. Repetition, not broad expertise, was the goal. As 1941 came to an end and 1942 began, an unforeseen result emerged. The time required to build Liberty ships started dropping at an astonishing rate. Kaiser's very first Liberty ship took 197 days from start to delivery. The second was completed in 169 days. By the fifth ship, construction time had fallen to 128 days. The 10th required only 97 days. By the spring of 1942, the Richmond shipyards were launching Liberty ships in an average of just 70 days. Across the country, established shipbuilders watched with increasing unease. Their highly trained veteran crews were being matched and in many cases surpassed by a workforce that had been dismissed as inexperienced and underqualified. The prefabrication system that traditional yards had ridiculed was proving remarkably effective. The secret lay in abandoning linear construction. Conventional shipyards built vessels step by step, starting with the keel and moving upward in strict order. Kaiser reorganized the entire process. Instead of constructing one ship piece by piece, his yards produced many large sections at the same time across different areas of the facility. While one crew assembled the bow in a prefabrication zone, others simultaneously worked on the stern, deckhouses, engine rooms, and bulkheads. Once these sections were finished, enormous cranes lifted them into position on the building ways, where welding teams joined them into a single vessel. Albert Wooding, a production supervisor at Richmond Yard No. 2, described this radical efficiency in a 1943 interview with Fortune magazine. In traditional shipbuilding, he explained, each task depends on the completion of the previous one. An engine cannot be installed until the engine room exists. The engine room cannot be completed until the hull is finished. Progress moves forward in a single, rigid sequence. Kaiser's system broke that chain. With parallel production, different teams worked independently and simultaneously. While one crew welded hull plates in the open yard, another assembled the ship's engine in a separate workshop. When both components were ready, the finished engine was simply lowered into the completed engine room and secured in place. Jobs that once stretched across weeks were compressed into hours. The numbers revealed just how dramatic the transformation was. In a conventional shipyard, installing an engine might involve 50 workers laboring for 3 weeks inside a cramped, partially built hull. Kaiser reversed the logic. He assigned roughly 200 workers to assemble the entire engine and its mounting structure in an open, well-lit workshop over 5 days. A crane then placed the completed assembly into the ship in a single 8-hour operation. Perhaps most unsettling to traditional maritime authorities was how casually Kaiser discarded centuries of established shipbuilding conventions. Ships had long been constructed from highly detailed blueprints that dictated every measurement and method. Kaiser replaced these with simplified drawings that outlined only essential dimensions. Many decisions were left to the judgment of workers on the floor. What had once been rigidly controlled by engineers was now shaped by production crews guided by speed, repetition, and experience. This unconventional approach, initially criticized as reckless, reshaped industrial shipbuilding and permanently altered expectations of what mass production could achieve under wartime pressure. For decades, established shipbuilders viewed radical simplification as carelessness. Henry J. Kaiser, however, saw the same approach as adaptability. To him, flexibility was not a flaw but a strategic advantage, especially in wartime. At the U.S. Maritime Commission, this philosophy initially met strong resistance. Vice Admiral Howard Vickery, the Commission's vice chairman and a seasoned naval officer, openly opposed Kaiser's proposal to reduce the level of technical detail in ship design drawings. In his view, shipbuilding was not an assembly line industry. Precision was essential and shortcuts invited disaster. Official meeting records from early 1942 show Vickery firmly rejecting Kaiser's requests, insisting that ocean-going vessels demanded standards far beyond those used in manufacturing automobiles or machinery. Yet reality soon began to undermine theory. By March 1942, reports showed that Kaiser's shipyards were completing vessels at a rate roughly 40% higher than traditional contractors. Just 3 months later, that advantage had expanded dramatically, approaching a 70% lead. Faced with undeniable results, Vickery's stance evolved. He later acknowledged a hard-earned lesson: striving for perfection can delay what is merely necessary. Kaiser's ships lacked elegance and refinement, but they functioned. And functional ships delivered on time carried more cargo than flawless ones still sitting unfinished in dry docks. As production accelerated through the spring and summer of 1942, a new dynamic emerged within Kaiser's own organization. His 7 shipyards, scattered across California, Oregon, and Washington, began to compete informally with one another. The rivalry was driven largely by 2 ambitious managers. Edgar Kaiser, Henry Kaiser's son, oversaw all operations as vice president and general manager, while directly managing the Oregon Shipbuilding Corporation in Portland. In California, Clay Bedford ran the sprawling Richmond shipyards. Both men were relentless, and both believed their facilities could outperform the other. By the fall of 1942, this internal rivalry had spilled into public view. Newspapers began tracking shipbuilding times as if they were athletic records, publishing updates that captured national attention. Milestones fell one after another, culminating in September when the Oregon Yard completed the Liberty ship Joseph N. Teal in just 10 days, a figure previously thought unattainable. Concerned that the spectacle was becoming a distraction, Vice Admiral Vickery eventually ordered an end to the speed contests, dismissing them as publicity stunts. Officially, the competitions stopped. Unofficially, they had already achieved their real objective. Across all Kaiser yards, workers now believed that extreme speed was not an anomaly. It was the new standard. The most dramatic demonstration came in November 1942. Vice Admiral Emery Esland, head of the Maritime Commission, visited Richmond to review progress. During a casual exchange with reporters, he remarked that Liberty ship construction had improved significantly, but still lagged behind the efficiency achieved in other mass production industries. The comment was overheard by Clay Bedford, who interpreted it not as criticism, but as a challenge. Bedford responded immediately. He proposed an unprecedented goal. Richmond Yard No. 2 would attempt to build an entire Liberty ship from the moment the keel was laid to the instant of launch in less than 10 days, cutting the existing record nearly in half. Admiral Land, skeptical but curious, granted approval on one strict condition: the experiment could not interfere with ongoing production. Bedford selected the 47th hull scheduled at Yard No. 2 for the attempt. The ship would bear the name SS Robert E. Peary, honoring the famed Arctic explorer. The effort began just after midnight on Sunday, November 8. More than 1,000 workers rotated through precisely synchronized shifts, executing a plan refined down to the smallest detail. Prefabrication, long a hallmark of Kaiser's method, was pushed to its absolute limit. Before construction officially began, every major section of the ship had already been fabricated, inspected, and positioned nearby. The bow, assembled from over 50 separate steel components, was fully welded and equipped with anchors, chain lockers, and crew accommodations. The stern arrived complete with steering systems, the propeller shaft, and aft living quarters. 4 enormous cargo holds, each a massive steel structure, were lifted into place as single units. Even the engine, a 140-ton triple-expansion steam plant built by the Joshua Hendy Ironworks in Sunnyvale, had been mounted, aligned, and tested before reaching the yard. Unlike conventional shipbuilding, which progressed slowly from keel to deck over many months, this vessel was assembled almost entirely from ready-made sections. After just 4 days, the hull stood complete. The engine was secured, deckhouses installed, cargo holds locked into position, and steering mechanisms fully mounted. On Thursday afternoon, November 12, at precisely 3:30 p.m., the SS Robert E. Peary slid into San Francisco Bay. The elapsed time since keel laying, 4 days, 15 hours, and 29 minutes. 3 days later, on November 15, the ship was officially delivered and ready for service, setting yet another record, just over 7 days from start to full completion. A large crowd witnessed the launch, including naval officials, military officers, rival shipbuilders, and journalists from across the country. Many had arrived expecting to see either an embarrassing failure or a vessel that merely looked finished while hiding serious flaws. What they saw instead was something far more unsettling to tradition, a fully functional ship built at a speed that permanently redefined what was considered possible in maritime construction. When observers arrived expecting to witness the unveiling of an unfinished hull, what stood before them was something entirely different, a complete, seaworthy vessel that needed only minimal final adjustments before joining active service. This alone signaled that a line long thought unbreakable had been crossed. Vice Admiral Emery S. Land, who attended the launch and addressed the crowd briefly while newsreel cameras rolled, gave voice to a realization many in the maritime establishment had been struggling to accept. His remarks reflected not triumph but astonishment. Only half a year earlier, he admitted, such an outcome would have been dismissed outright. For 3 millennia, shipbuilding tradition had insisted that a proper ocean-going vessel could not be produced in mere days. That belief, painstakingly reinforced over generations, had just been rendered obsolete. Henry J. Kaiser had done what centuries of accumulated wisdom claimed was impossible. The implications were immediate and unavoidable. The United States Maritime Commission swiftly announced that all shipyards operating under government contract would be required to adopt the production methods demonstrated in Kaiser's facilities. For the established shipbuilding community, this directive landed with the force of a shockwave. Long-respected yards that had previously ridiculed Kaiser as an unschooled interloper began dispatching their best engineers to study his techniques firsthand. One of the clearest indicators of this intellectual reversal came late in 1942. The president of New York Shipbuilding Corporation, one of the nation's oldest and most prestigious maritime firms, traveled to Richmond to observe Kaiser's operations. Upon his return, he submitted a confidential assessment to his board of directors. The report left no room for ambiguity. The foundational assumptions of traditional shipbuilding, he concluded, had collapsed. Kaiser had succeeded precisely because he refused to accept the limits the industry had imposed on itself. Where conventional yards treated shipbuilding as an artisanal craft, Kaiser approached it as an industrial manufacturing challenge. He stripped away unnecessary complexity. He favored standardization over bespoke refinement. Instead of relying on workers who had inherited skills across generations, he created systems that allowed large numbers of previously untrained laborers to become productive in weeks. The outcome was undeniable. Ships completed in roughly 1/10 the time and at approximately 2/3 the cost. The industry faced a stark choice: adapt or fade into irrelevance. By the beginning of 1943, the ripple effects of Kaiser's methods had reshaped American maritime production. 18 shipyards across the country were now assembling Liberty ships using prefabricated sections and welded construction. What initially took an average of 230 days was reduced within months to just over 6 weeks. By mid-year, the United States was launching an average of 3 Liberty ships every single day, an output that surpassed the destructive capacity of German U-boats. Yet perhaps the most disruptive aspect of Kaiser's revolution was not speed or volume, but people. The workforce filling his yards stood in direct contradiction to centuries of guild-based labor hierarchy. Tens of thousands of women, racial minorities, and individuals with no prior industrial experience were now building complex ocean vessels. Their success challenged deeply held beliefs about skill, authority, and who was deemed capable of skilled work. At the height of production in 1944, Kaiser's 7 shipyards employed nearly 200,000 workers. More than 40,000 of them were women, a striking figure for the era. In Richmond alone, women accounted for over a quarter of the production workforce by mid-1944. The 3 Kaiser yards in the Pacific Northwest employed more than 31,000 women combined. African American workers were present in similarly unprecedented numbers. They filled roles not only in manual labor but in skilled trades such as welding and fitting as crane operators, and even in supervisory positions. For 1942 America, this level of workplace integration was extraordinary. The implications extended far beyond wartime necessity, touching the very structure of American labor and social organization. Kaiser's shipyards demonstrated that complex industrial production no longer required lifelong apprenticeships or inherited expertise. With the right systems, training, and organization, skill could be created rather than preserved. This insight quietly undermined centuries of labor orthodoxy. The cultural transformation within Kaiser's operations was visible even during moments of national tradition. Christmas of 1943 offered a revealing example. While most shipyards reduced operations for the holiday, Kaiser's facilities maintained full schedules. Yet this continuity was paired with recognition rather than coercion. Workers on shift were served full Christmas dinners complete with turkey, ham, and traditional sides free of charge in yard cafeterias. Church choirs sang carols, local bands performed. Kaiser himself toured the yards, greeting workers personally and thanking them for their contribution. By mid-1944, Kaiser's yards had produced more than 800 Liberty ships. Across the nation, the 18 shipyards engaged in Liberty ship construction had collectively launched approximately 2,400 vessels. Production soon expanded to Victory ships, larger, faster designs built using the same modular and welded methods. Between 1941 and 1945, American shipyards delivered over 5,500 merchant vessels, totaling roughly 53 million tons of shipping capacity. Even by modern standards, the scale remains remarkable. Allied observers took notice. Commander Joseph Kenworthy of the Royal Navy, assigned to the British Admiralty delegation in Washington, monitored American output closely. His reports, declassified decades later, captured a mix of admiration and unease. The United States, he observed, was producing merchant shipping at a rate greater than that of the rest of the world combined. Kaiser alone, month by month, surpassed the entire British shipbuilding industry in tonnage. From the British perspective, the methods appeared inelegant. The ships lacked refinement. They were not masterpieces of naval architecture, but they floated, they carried cargo, and there were thousands of them. Britain had spent years crafting the finest warships afloat. America was producing serviceable ships in weeks. And in modern warfare, Kenworthy concluded, adequacy multiplied by thousands would always defeat perfection multiplied by dozens. One of the most extraordinary elements of Henry J. Kaiser's story did not unfold during the height of the Second World War, but rather in the uncertain months that followed its conclusion. As victory approached, most economic analysts were pessimistic about the future of America's wartime shipbuilding empire. They assumed that the sudden end of military demand would trigger a dramatic collapse. Shipyards would fall silent, vast industrial complexes would be left idle, and tens of thousands of skilled and semi-skilled workers would be cast into unemployment almost overnight. In many ways, those forecasts were correct. Production of Liberty ships officially stopped in September 1945. Within just 3 months, Kaiser's workforce shrank at an astonishing pace from roughly 200,000 employees to fewer than 20,000. The once booming shipyards at Richmond, California, which had employed around 100,000 workers at their wartime peak, stood largely deserted by the spring of 1946. Cranes loomed motionless over empty slipways, and the urgency that had once driven round the clock production vanished almost instantly. Yet, while the physical activity ceased, the intellectual and technical legacy of Kaiser's emergency program did not fade. The knowledge accumulated during those intense years, methods of large-scale prefabrication, advanced welding techniques, and parallel assembly processes did not disappear with the workers. Instead, these innovations quietly reshaped the future of global shipbuilding. What had begun as a desperate wartime experiment became the blueprint for an entirely new industrial standard. During the post-war decades, nations rebuilding their maritime industries took careful note of what Kaiser had accomplished. In the 1950s and 1960s, Japanese and South Korean planners closely examined the Liberty ship program, studying how speed, scale, and efficiency had been achieved. They adopted Kaiser's methods as the structural foundation of their own shipyards. The massive industrial complexes that later rose in places such as Ulsan in South Korea and Nagasaki in Japan, yards that would dominate global ship construction for generations, were direct heirs to the revolutionary practices first implemented at Richmond. This enduring influence was succinctly captured by maritime historian John Bunker of the State University of New York Maritime College. In his landmark 1972 study, Bunker described Kaiser as a complete outsider to the maritime world, a man with no deep roots in shipbuilding tradition and no reverence for long-standing customs. Unburdened by conventional thinking, Kaiser freely applied industrial manufacturing principles that established shipbuilders had long dismissed as unsuitable. The results were unprecedented. In just 3 years, Kaiser oversaw the construction of more ships than the United States had produced during the entire previous century. More importantly, he permanently transformed how ships would be built across the globe for the rest of the 20th century. The construction methods Kaiser championed, modular design, extensive prefabrication, and welded assembly, are now universal. Whether modern yards are producing container ships in Korea, oil tankers in Japan, or cruise liners in Europe, they all rely on techniques that can be traced directly back to the Liberty ship program. Today's global shipbuilding industry stands on foundations first laid during that wartime emergency. The scale of Kaiser's achievement becomes even clearer when examined through production data. Between 1941 and 1945, American shipyards constructed a total of 2,710 Liberty ships across 18 facilities. At peak output, this translated to an astonishing average of nearly 2 ships launched every single day. Kaiser's 7 shipyards alone accounted for 1,490 vessels, approximately 27% of all U.S. wartime merchant ships built under maritime commission contracts. Efficiency improved at a pace few believed possible. Early Liberty ships required roughly 230 days to complete in 1941. By 1943, average construction time had fallen to just 42 days. One ship, the Robert E. Peary, set a record that became legendary. It went from keel laying to launch in only 4 days and 15 hours. Labor productivity followed a similar trajectory. Initial ships consumed around 1.1 million labor hours each. Within 2 years, that figure had dropped to approximately 486,000 hours per vessel. Kaiser's most efficient facilities, Richmond Shipyards No. 2 and No. 3, pushed this even further, completing ships in as few as 350,000 labor hours. They achieved this by operating continuous 3-shift schedules and maximizing the use of prefabricated sections assembled simultaneously. Cost reductions mirrored these gains. Early Liberty ships carried price tags between $1.75 and $2 million apiece. By 1943, despite rising wages and material costs, the average price stabilized around $1.8 million, a clear reflection of improved efficiency and learning curve effects. In operational terms, Liberty ships were far from symbolic. Fully loaded, each vessel displaced 14,245 tons and could carry up to 10,800 tons of cargo. A single voyage could transport approximately 2,840 jeeps, 440 tanks, or an astonishing 230 million rounds of ammunition. Power came from triple expansion steam engines, intentionally old-fashioned designs chosen for their reliability, simplicity, and ease of mass production. With a top speed of about 11 knots, the ships were fast enough to function effectively within Allied convoys. Equally impressive was the speed at which Kaiser built his workforce. Specialized training schools prepared workers for specific tasks in an average of just 2 weeks. In some cases, spot welders were fully productive after only 10 days. More demanding roles, such as crane operation or ship fitting, required 4 to 6 weeks. This stood in sharp contrast to traditional maritime apprenticeships, which typically demanded 4 years for basic competence and up to a decade for master status. Kaiser's system emphasized specialization over comprehensive craftsmanship. Workers repeated narrowly defined tasks hundreds of times, achieving speed through repetition rather than broad mastery. Skeptics initially doubted whether such rapidly built ships could survive the realities of war. Combat data ultimately answered those concerns. Of the 2,710 Liberty ships produced, around 200 were lost to enemy action, a loss rate of approximately 7.4%. This compared favorably with pre-war merchant shipping statistics and demonstrated that welded construction, once viewed with suspicion, could produce seaworthy vessels. Structural problems did occur, particularly early on. Welding defects and brittle steel led to nearly 1,500 significant fracture incidents across the fleet. In 3 extreme cases, just 0.11% of all ships' vessels fractured completely in half. These failures prompted immediate investigation, leading to improved welding practices and revised steel specifications. By 1944, the problem had been effectively eliminated. The final verdict on Kaiser's methods came not during wartime, but in the decades that followed. Liberty ships had been designed as temporary emergency vessels, with an expected service life of only 5 years. Instead, many remained active for generations. The SS John W. Brown, launched in 1942, still operates today as a museum ship in Baltimore more than 8 decades after its construction. The SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and famously sailed under its own power to Normandy in 1994 for the 50th anniversary of D-Day. A third vessel, the SS Hellas Liberty, stands today as a museum ship in Greece. Out of the roughly 2,510 Liberty ships that survived the war, about 835 continued operating in commercial service well into the 1,960s, far beyond any expectation held by their designers. What began as a hurried wartime solution ultimately proved to be one of the most durable and influential industrial achievements of the modern era. After World War II, many Liberty ships were sold to international shipping companies, where some remained in operation well into the 1972s. Among them, the SS Albert M. Bow, which holds the distinction of being the final Liberty ship completed on October 30, 1945, avoided the scrapyard entirely. Instead, it underwent a transformation in 1965 into the fish processing vessel Star of Kodiak, after being sold in 1964 for $65,557. Remarkably, the hull of this ship survives today, repurposed as the land-based headquarters of Trident Seafoods in Kodiak, Alaska, an enduring legacy nearly 8 decades after its construction. The Liberty ship program generated a profound ripple effect across the American industrial landscape. The enormous demand for steel stimulated rapid expansion of production facilities, particularly on the West Coast. To supply his shipyards, industrialist Henry Kaiser established the Fontana Steel Mill in California, which came online in 1942, 5 months ahead of schedule. This mill alone produced roughly 700,000 tons of steel annually, cementing California's role as a major steel-producing region for the first time. Kaiser's wartime projects also extended to the production of essential materials such as magnesium for incendiary munitions and aluminum for aircraft, all manufactured in facilities specifically built to support integrated war production. The economic effects were immediately visible in the communities surrounding these industrial centers. Richmond, California, for instance, saw its population soar from 23,000 in 1940 to more than 100,000 by 1943, fueled almost entirely by employment in shipyards and related industries. In Oregon, Kaiser orchestrated the creation of Vanport City, which temporarily became the state's second-largest city, hosting over 40,000 residents, all connected to shipbuilding work or supporting services. Though these boom towns were largely transient, they illustrated the transformative power of concentrated industrial investment in shaping urban growth and labor markets. Unexpectedly, Kaiser's shipbuilding initiatives also fostered innovation in healthcare. To meet the needs of his enormous workforce, he collaborated with physician Sidney Garfield to develop prepaid medical care programs. These early initiatives eventually evolved into Kaiser Permanente, now one of the largest health maintenance organizations in the United States. The preventive care model, first tested in the shipyards, left a lasting imprint on American medicine, reaching over 12 million members by the early 2000s. The shipyards also opened doors for thousands of young workers, particularly women and minorities, providing skills and professional opportunities that would have been largely inaccessible under traditional employment pathways. Many of these individuals carried the lessons learned during the war into their post-war careers, influencing industries far beyond maritime construction. Technological advances from the Liberty Ship program, particularly welding techniques developed under the intense pressures of wartime production, became standard in structural steel construction, refinery equipment fabrication, and pressure vessel manufacturing. Similarly, the use of prefabricated components pioneered in Richmond reshaped practices in housing construction, bridge engineering, and industrial facility development. Organizational innovations introduced in the shipyards, such as parallel production lines, simplified design specifications, and accelerated worker training, also laid the groundwork for modern operations management and industrial engineering principles. In a 1985 study on American industrial competitiveness, Harvard Business School professor Michael Porter highlighted the Liberty Ship program as a prime example of rapid capability development. Kaiser's efforts demonstrated that industrial potential is not a static quantity but can be dramatically expanded when necessity and organization converge. When the United States entered World War II, its capacity for merchant shipbuilding was minimal. Yet, within just 2 years, American shipyards produced more tonnage than all other nations combined. This achievement underscored a broader principle. Apparent limitations on industrial capacity often stem more from organizational and conceptual constraints than from physical or technical impossibilities. The Liberty Ship program, in both its technological and social dimensions, remains a powerful illustration of how coordinated effort and strategic investment can reshape industries, communities, and even national capabilities in a remarkably short period. The psychological shift brought about by the Liberty Ship program among engineers and industrial managers proved to be as consequential as the fleet of ships themselves. Prior to Henry Kaiser's interventions, industrial leaders largely accepted conventional assumptions regarding production limits, required skill levels, and organizational design. Kaiser's approach challenged this orthodoxy, showing that widely held beliefs could be flawed and that extraordinary productivity demanded a willingness to question the very foundations of industrial practice. The narrative of the Liberty ships serves as enduring evidence that human potential and industrial possibility are far greater than tradition would suggest. While the vessels were critical to the Allied war effort, their construction's true significance lay in what it revealed about people's capacity to achieve remarkable outcomes. With appropriate training and opportunity, ordinary workers could master complex tasks, producing sophisticated products in a fraction of the time previously considered necessary. Industries that had resisted substantial change for centuries were rapidly transformed when necessity drove innovation. Admiral Chester Nimitz, commander of the U.S. Pacific Fleet, reflected on this industrial impact in his post-war memoir published in 1960. He observed that across 5,000 miles of the Pacific theater, American forces were consistently supplied by ships built faster than the enemy could destroy them. Japanese planners assumed that while American industry was formidable, it had limits. They believed that sufficient losses at sea would eventually strain logistics to the breaking point, forcing a negotiated settlement. They failed to consider Henry Kaiser. By 1944, the US was replenishing ships at a rate that exceeded enemy sinkings. Simple arithmetic favored production over destruction. 3 ships built per day outpaced 2 ships lost. The decisive factor in the Pacific campaign was industrial output rather than individual heroism, proving that victory was as much engineered in the shipyards of Richmond, Portland, and Baltimore as it was earned on the beaches of Iwo Jima and Okinawa. Kaiser's most enduring accomplishment was not the 1,490 ships his shipyards produced, but the transformation in industrial thinking he inspired. The construction of the Robert E. Perry, completed in under 5 days, became a tangible demonstration that conventional practices were not infallible and that radical performance gains required equally radical rethinking of processes. Initially dismissed by the maritime establishment as an inexperienced outsider, Kaiser's methods were studied and gradually adopted for decades after the war. Workers who acquired welding, fitting, and fabrication skills under wartime pressures carried these competencies into post-war careers, contributing directly to the rebuilding and growth of the American economy. Techniques that emerged in response to urgent wartime needs became standardized practices in peacetime manufacturing, influencing industries globally. The Liberty Ship program illustrates a broader lesson about transformation through demonstration. Innovation often originates outside established traditions. Progress demands re-evaluation of perceived limits, and human capacity exceeds expectations when supported by proper organization and challenge. Kaiser's workforce achieved extraordinary results not due to innate superiority but because systems were designed to empower them and belief in their capability was actively cultivated. The principle that ordinary individuals can accomplish seemingly impossible tasks when given opportunity and structure was vividly proven in Richmond and replicated across other shipyards, resulting in 2,710 completed vessels. Though nearly all Liberty ships have been dismantled or lost to the ocean, the paradigm shift they represented persists. Modern shipbuilding, prefabricated manufacturing, rapid skill training programs, and management philosophies that question presumed limits all trace roots back to the lessons proven by Kaiser's initiatives. From signing his first contract in December 1940 through the extraordinary launch of the Robert E. Perry in November 1942 to the final Liberty ship delivery in September 1945, Kaiser demonstrated that each of the 2,710 ships delivered between 1941 and 1945 carried more than goods or troops. They embodied the demonstration that, when liberated from tradition and guided by necessity, human ingenuity can realize what was once considered impossible.